In this video, we're going to discuss the difference between 2D space and 3D space.
Obviously very, very important as you guys begin your journey into the world of 3D.
That's right. So, where to begin? Let's just begin with the simple line of things, which is 2D space.
That's right.
And you see 2D space everywhere you look. It's right here on your screen. Your screen is two-dimensional right now. 2D space is going to use two directions, also known as axes, to designate a position. And you guys have all seen this. Each and every one of you, if you've ever taken any sort of high school math class at some point in your lives, you've seen that two-dimensional grid. And that grid had two axes. You had the x-axis, which runs horizontally across the grid, and the y-axis that runs vertically across the grid. Coordinates are always listed with the x-axis first, then the y-axis. Examples are xy 24, 8, -3, and 16. So to give kind of a visual example of this, here's a nice diagram of two-dimensional space. We have the y-axis in the positive direction. We have the y-axis in the negative direction. X positive, x negative. If you want to try to locate a point in two-dimensional space, all you need to do is count the grid spaces. You count 1, 2, 3, 4, 5, 6 over, and then 5 up, and you get a coordinate of 6, 5. And you can do that with any of these. You can count off -15 spaces, down 10, so you get -10 as well. -11, +13, get you up into that area. So, it's kind of interesting how this is working. So how do we know which number is going to be positive and which number is going to be negative? That is because this grid is divided into quadrants.
That's right.
The upper right quadrant being positive and positive, upper left being negative for x, positive for y, lower left being negative for x, negative for y, and lower right being positive for x and negative for y. Now, the center of the grid is going to have a coordinate of 0, 0. That's going to be also known as the origin on any grid.
Get used to that name. You're going to hear the origin quite often when
Absolutely.
working inside of Maya.
Whenever we're talking about the center of our scene, we will often say the origin. And in Maya, you're also going to see a grid that looks exactly like this, a grid with X and Y visible, except it's not going to be a kind of top-down grid like you'd think of on a piece of paper. It's actually going to be like a front view grid. So if you had a character in Maya, they would look something like this.
Right.
So you'd be kind of staring right down their chest. That's the general gist of two-dimensional space. Now when you move over to 3D space, the rules change up a little bit. Now these 3D space rules that I'm going to give you are specific to Maya, and I'll explain what I mean by that here in just a moment. First off, 3D space uses 3 directions or 3 axes to designate a position instead of 2. The x-axis is going to run horizontally left to right. Think about the three-dimensional world you are in right now. You are sitting at a desk. You are looking at a computer monitor. To your left and to your right would run your local x-axis. Dun, 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 dun. Let me scroll up in my layers real quick. The y-axis is going to run vertically, up and down. So a y-positive motion for you would be to go up. A y-negative would be to go downward. The z-axis runs horizontally forward and backward. Think of an axis that goes right out of your chest and right out your back. And then finally, coordinates in 3D space are listed in the order of x, y, and z. So examples would be something like 23, -5 and 7, -12, 16, and -35.2. I threw a little decimal point in there to kind of mix things up a little bit.
Sure. I would like to go ahead and point something out. In this course, you guys will hear us bounce back and forth between Z and Z.
Yeah.
Zach and I have both trained a lot of people over the years, both from the United States and all sorts of foreign countries.
UK, Canada.
And we've gotten so used to saying Z because of extended times with other people from other countries that weren't used to hearing Z.
But we grew up saying Z, so we flip back and forth a lot.
Just so you're aware.
So, also, notice this. I have color-coded X, Y, and Z. X is red, Y is green, and Z is blue. RGB.
Ooh.
RGB equals XYZ. A little thing, I want you to know that. Keep that in your head. I'm going to plant a little seed right now. So, those are the rules for 3D space. Very basic. Now, the reason these are Maya-specific rules is that in Maya, the y-axis points up and down. In some other applications, the y-axis doesn't always point up and down. But we're not really worried about other applications. For now, all you need to worry about is x is left to right, y is up and down, z is typically forward. All right. So with that, let's go ahead and take a look at a three-dimensional diagram. So this is like what a three-dimensional space is going to look like. And if we were to kind of, and let me do this. I'm going to go ahead and create a new layer. This will be cooler. I'll grab my paintbrush. Now, how do we find a space in three-dimensional, or how do we find a point in three-dimensional space? Very simply, we count out the x, the y, and then the z. So if I were to take, I don't know, a point that was over here. Now, it looks like I'm drawing on the back wall, but think of this like a point that is literally floating in space. We would count out the number of units in x to lead over to it, so that would take us something like this. Then the number in y, so we'd go up in y, and then the number in z to finally get our coordinates. So this would be something like 3, and then maybe 7 and 5. So that would be the actual location of this object in 3D space. And I'll actually show you this here in just a moment. If you remember that character I showed you in two-dimensional space? Here's how he would look in 3D space.
Bink.
Bink. It's the exact same thing. I mean, our origin would be right about his chest level, and now you can see that he's kind of filling a three-dimensional area, a 3D space. He's not just a simple flat object. So how does this pertain to Maya? Well, in Maya, your entire world, the viewport that you begin by looking into, and don't worry, we're going to go over everything you see here. Just kind of think of this as 3D theory, and don't worry about the Maya end of things. This is a three-dimensional world. We can rotate around it. It is not a single flat piece of paper. Although your grid does indeed appear flat, I could create something like a cube, and we can rotate around that cube. That cube is not a simple two-dimensional object. As you can see, it exists in 3D space.
You'll also notice that as Zach rotates around his grid, that in the lower left-hand corner, we have an axis icon that's letting you know which way is X, which way is Y, and which way is Z.
That's right. So, and also, it's color-coded just like I showed you earlier.
Sure is.
Red for X, green for Y, and blue for Z. Now, how do you know where a point is going to be in 3D space as it pertains to Maya? Let me create a very special object called a locator. All it is simply a designator for a point in space. Now, currently, if we look at our translates, and that is where an object happens to exist. That is its location in 3D space. They are all set to 0, 0, and 0.
He is currently at the origin.
That's right. If I take my translate x, which is my, again, location in x, and I set this to, say, positive 5. Look at this. The locator jumps over 5 units in the x direction. You can see down here in the lower left-hand corner, that is indeed the x-axis. If I were to set this to maybe negative 7, we would jump in the opposite direction.
And if you count out the little squares there, you'll find that it's
1, 2, 3, 4, 5, 6, 7.
7 units back.
I can still count. It's amazing.
You sure can.
All right. Then we can take translate y and set that to a value of 4 or something like maybe negative 6. And now we go down underneath the grid because we're moving in a negative or downward direction. So let's set this maybe up to 4, so we're just kind of floating up here. Then, of course, we have translate z, position in the z-axis, or what is typically the forward axis. We could set this, I don't know, maybe 8. Now we've moved forward 8 units. And if you combine the 3 of these numbers, you will get an object's physical location in 3D space. If you're not used to it, if you're completely new to 3D, this will take some getting used to. So practice this. As we get into Maya, after you've seen the interface, try out just moving objects. Try just getting an idea of where things exist in 3D space.
The more and more that you play with it, the quicker you'll find that it becomes no big deal.
Indeed. So really, that's all I want to talk about in this video. Just a way to kind of get you grounded in 3D and how it derives itself from 2D.
The bottom line is this. Pull out a piece of paper. Draw a happy face. Draw something. You're working in 2D space.
That's right.
3D space, look around the room you're in right now.
Yeah.
That's 3D space. You need a height and left and
Length,
right
width,
axes.
depth,
And the depth to pinpoint where a particular object is. It's
That's
very
right.
important. And again, the more and more that we go into the course, the more comfortable you're going to become working in 3D space. You guys will see, especially after you get to the end of the first project.
Absolutely.
So with that, that's going to basically wrap up this lesson here, and we're ready to start taking a closer look at Maya. Thanks a lot, guys.